So, hello all and very good afternoon to all. I hope my screen is visible to all of you and my voice is also audible, right? Just give me a confirmation so that we can start our today session. My screen is visible to all of you? Hmm? Chalo. Very good. So, in this class, basically, we are going to cover the remaining part of ethers and try to do some questions as well, right? So, as we all know, I'm Vivek Tiwari from the Department of Chemistry. So, I'm going to take the session for the today class, right? So, this is the fourth class of this chapter, that is alcohol, phenol, and ether. In previous three class, we already discussed alcohol, phenol, and their physical, chemical properties, their method of preparation, and also do a various type of questions from IIT and NEET as advanced level. Right now, so what is the learning objective of the today class? क्या है भाई learning objective आज की class का? So basically in this class we are going to study ethers, their method of preparation, their physical and chemical properties, and at the end of the lesson you are able to solve problem related to the ethers, right? So these are the learning objective of today class. I hope this is clear to all of you. Yeah. Let me quickly revise the previous topic by just doing a recall test, right? So I request all of you to just try to answer this question, right? So this is the recall test. We already studied this thing in the previous class. Okay. So given below are the two statements, that is statement one and statement two. The statement one state that in a Lucas test, primary, secondary, and tertiary alcohol are distinguished on the basis of their reactivity with the concentrated HCl and ZnCl2, known as Lucas region. इस स्टेटमेंट वन इज करेक्ट क्या? स्टेटमेंट वन करेक्ट है क्या? सब बताओ जल्दी से फटाफट. Yeah. And what is statement two? That is the primary alcohol are most reactive and immediately produce turbidity at the room temperature on reaction with the Lucas reagent. So in light of the above statement, choose the most appropriate answer from the option given below. Yes, I'm waiting for a reply all. सभी को रिप्लाई करना है, सभी को अपने अपने आंसर्स बताने हैं, बिकॉज हम लोगों ने लुकास टेस्ट अच्छे से किया था विद द explanation as well, right? Yeah, out of primary, secondary, and tertiary, which react faster and in which turbidity appears immediately. In some turbidity appears after 5 minutes and some in turbidity does not appear. So you have to identify whether it is a primary, secondary or tertiary. So I'm waiting for a reply, guys. फटाफट reply करो जल्दी से. क्या होना चाहिए आंसर? Yes, I got one answer. GNP Bhavnagar. Yeah. GNP Bhavnagar state that C, statement 1 is correct, but statement 2 is incorrect. Good. Anyone else? कोई और बताना चाहेगा क्या? जल्दी फटाफट. कोई और बताना चाहेगा क्या? क्या होना चाहिए इसका आंसर? जल्दी. यस, मुझे और दो रिप्लाईज मिले हैं. जेएनबी गांधीनगर, जेएनबी नांदेड़. वेरी गुड बेटा. सी. सो सभी बच्चे सी बोल रहे हैं. इट मींस एब्सोल्युटली करेक्ट. दैट इज सी. स्टेटमेंट 1 is correct because Lucas reagent is, we all know that concentrated HCl plus ZnCl2, and this Lucas reagent is used to distinguish between what beta? They are used to distinguish between primary, secondary and the tertiary alcohol. And how they distinguish? So बहुत सिंपल सा तरीका है. Primary alcohol does not react, does not produce turbidity at all, right? GNB is one present. Very good, beta, right? So good. And if I'm talking about the tertiary alcohol, so turbidity appears immediately. So the order of reactivity is like 3 degree, that is 3 degree, 2 degree, and 1 degree, right? So this is the correct order of reactivity. So absolutely the statement 2 is incorrect because in this they are given primary alcohol are most reactive, which is not the correct one, right? So option C, that is statement 1 is correct, but the statement 2 is incorrect. So this is absolutely correct answer for this. Okay, let me quickly do one more recall test, right? So this is the structure of the intermediate A in the following reaction is. So you have to identify the intermediate form in this reaction. So this is a very famous reaction. Can anyone name the reaction? Which reaction is this? This is a very famous reaction for the preparation of phenol. Can anyone name this reaction? क्या बोलते हैं इस रिएक्शन को? कोई भी बताना चाहेगा क्या? What this structure called? इस स्ट्रक्चर को क्या बोलते हैं? And this method is very, very important because in this we get phenol as well as acetone. Yes, एक reply है cumene. JNV Anand, very good beta. Cumene, right, very good. So this is isopropyl alcohol, or we say we have this is also called cumene. Very good beta. Cumene. Okay. Now, what is the intermediate of this product? Can anyone tell me what is the intermediate of this product? चलो, कोई बताएगा क्या? Yes, 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 I got one. Cumene hyperperoxide. Very good बेटा. Cumene hyperperoxide. किसने बोला है? Very good, very good, very good. Right. So cumene hyperoxide is the correct answer for this question. Right. So cumene hyperoxide. How will you draw the structure of cumene hyperoxide? How will you draw the structure of cumene hyperoxide? Yes, whenever cumene is react with O2, what they will form? So what A will form beta intermediate? That is nothing but cumene hyperoxide. So how will you draw the structure? The structure looks like that is C. This is CH3. This is again CH3. And here we have two oxygen peroxide linkage, right? So this is the structure of cumene hyperoxide. This is the structure of cumene hydro peroxide, right? So this is the structure beta, cumene hydroperoxide. So the structure of intermediate A in the following reaction is this. So I hope सबको ध्यान में आ गया होगा. हम लोगों ने सभी methods of preparation already cover कर लिया है in methods of preparation of phenol, right? So let's start with the today class. Recall test हम सबका हो गया अच्छे से. So let's start with the ethers. Okay. So what is ethers, beta? Basically, how will you define ethers? So ethers are the organic compound in which oxygen atom is bonded to two alkyl group, or we say two aryl group as well. So this is called ether, right? Thus we can represent ether as ROR. So here is oxygen, and this oxygen is surrounded by two different or same alkyl group. This R and R dash may be same, or this R or R dash may be different, right? So this R and R dash may be alkyl or aryl group as well, right? हो सकता है यहाँ पे एक CH3 group हो, यहाँ पे एक phenyl group हो. So this R and R dash will be alkyl or aryl group. This R and R dash will be same or different. So it depends, right? Now, when the two substituents group, that is R and R dash, both are identical, then ether is called symmetrical ether. For example, if we have CH3O and CH3, so this is called symmetrical ether, right? This is called symmetrical ether. Why this is called symmetrical ether? Can anyone? This is called symmetrical ether because both R and R dash are equal, right? So this is named as methoxymethane. So later we are going to name this as well. So this is known as methoxymethane. On the either side of O, both alkyl group are of same, that is containing one carbon, right? Now, if I take CH3, CH2, O and CH3. So this is an example of asymmetrical ether. Why? Because here only methyl act as alkyl group, where here in this case ethyl act as alkyl group. So the number of carbon atom on the either side of oxygen is different. So whenever the number of carbon atom on the either side of the oxygen is different, then it behaves as a asymmetrical ether. So always remember this thing. Symmetrical ether and asymmetrical ether. If the two same group are present, they are called symmetrical ether. Otherwise, if these two group are different, then the ether is known as asymmetrical ether. सबको clear है यहाँ तक? Ether का introduction part? Yes. Is it clear to everyone, right? What is the ether? What is the symmetrical and asymmetrical ether, and how will you represent ether? Right? Very good. Right? Good. Chalo. Now, so this is also an example of a symmetrical ether. Here we can say that this is CH3, CH2, CH2, CH3, known as ethoxyethane. And this is an example of a symmetrical ether, that is methoxyethane, right? So I'll give you one important note here, beta. Those who facing problem in name of their ether compounds, always remember smaller group That is, smaller group is always taken as alkoxy. Always remember this thing, right? Smaller group is always taken as alkoxy and the bigger group is taken as alkane. For example, in this case, either side of oxygen, we have a smaller group like only one carbon here. Here we have a two carbon. So always take a smaller group as alkoxy. So here we name as methoxyethane, right? This is named as methoxyethane. Now, in this case, if we have like CH3, CH2O, CH2, CH2, and CH3, then which is a smaller group? Which one is a smaller group? This ethane. So this is known as ethoxypropane, right? This is known as ethoxypropane. So always remember one thing, a smaller group is always taken as alkoxy and the bigger group is always considered as alkane, right? So these 2 points are very important while naming of ether, right? That is, smaller group is always taken as alkoxy and the bigger group is always taken as alkane. Clear hai sabko? Right. Now, the oxygen atom of ether can also be a part of the ring, in which case the ether is known as a cyclic ether, right? So this is an example of cyclic ether, that is THF. So this THF act as a solvent in many organic reaction, right? That is tetrahydrofuran. So tetrahydrofuran is one such cyclic ether which is used as a solvent in many organic reactions, right? So ethers are commonly used as a solvent for the organic reaction. The symmetrical ether shown above is diethyl ether and is commonly also referred simply as ether because of its wide use as a solvent. ठीक है? तो बहुत ही अच्छे solvent की तरह काम में आते हैं ethers, right? Good. So these are the general introduction of the ether. The example of cyclic ether is tetrahydrofuran. Just remember this point. Clear? Chalo. Now, if we talk about the structure of ether, right? If we talk about the structure of ether. So what is the structure of ether? So very interesting structure of ether is there. Basically in ether, the 4 electron pairs is there, right? How we say there is a 4 electrons pair? The 2 bond pair and the 2 lone pair of electron on oxygen atom, right? So how they arrange themselves? Because we know that what is ether? That is nothing but R, O and R, right? So we know the oxygen having 2 lone pair of electron and they having 2 bonds, right? So this oxygen having 4 electrons pair, 2 bonded and 2 lone pair of electron, right? Now, the carbon-oxygen bond length is around 141 picometer and is almost same as in alcohol, right? As case of alcohol, the carbon-oxygen bond, in case of ether also, the bond length is quite similar, like around 140 to 141 picometer, right? So how will it draw the structure? So this is in a structure of the ether. Now, here very interesting question arises, right? If you look at the structure of ether, you get to know the bond angle is 111 degree, right? So why the bond angle is 111 degree? Because we know that in case of tetrahedral, or we say in case of sp3 hybridization, right? In case of sp3 hybridization or in case of tetrahedral, bond angle is supposed to be 109 degree. So in case of sp3, bond angle is supposed to be 109 degree, right? So bond angle is supposed to be 109 degree. But why in case of ether, even they are tetrahedral and sp3 hybridized, why the bond angle is 111 degree? Can you explain the reason for this? Why the bond angle is 111 degree? So there is a very important, can anyone wants to say anything about this? Why the bond angle become 1117 degree, increase by around 2.7 degree? Why? Ether में bond angle, even their hybridization is sp3, they are tetrahedral, तो इनका bond angle तो 109 डिग्री होना चाहिए. फिर इनका bond angle 111 डिग्री क्यों हो गया? Why? Why this is happening? Yes. bulky groups on both sides of the oxygen. GNV Chalangan. Very good, beta. So it is due to the bulky group, right? Okay. In Vesper theory, we study due to the lone pair angle reduces, right? We study this thing due to lone pair. But what is the correct order for the repulsion? So we know that alkyl repulsion, that is alkyl repulsion dominate over lone pair repulsion, right? Always remember this thing. Alkyl repulsion dominate over lone pair repulsion. So due to presence of two bulky group, that is CH3, the repulsion is more, right? The repulsion is more. And due to this only, the bond angle tends to increase from 109 degree to 1111 degree, right? So this is a very important note here. Even they have a sp3 and tetrahedral arrangement, but their bond angle is increased by 2.5 degree. Why this is? This is due to presence of two bulky group only. Clear है सबको ये? चलो next. So basically the bulky R group result in the greater force of repulsion, and thus the bond angle is 1110 degree. So it is somewhat greater than the normal tetrahedral bond angle, around 109.28 minutes, right? Thus we can say that ether have a bent structure like H2O, and they are dipolar nature. So they are having the dipolar nature. How will you say that? They are having the dipolar nature. So very important thing, the structure of ether is not like this. If the structure of ether like this, then their dipole moment is supposed to be 0. Because we know that for the linear molecule, dipole moment is 0. But in actual, the structure of ether is like this. That is OR, bent shape. And due to this, they have oxygen having more electronegative. So they are having two negative charge, right? They are having partially positive, partial positive. Right. So they are dipolar in nature, right? So they are the dipolar in nature, and their dipole moment is not equal to 0, right? So this is a very important thing. If someone asks, what about the dipole moment of ether? The dipole moment of ether is not equal to 0. They show some dipole moment, right? Because they having a structure, not having a linear structure. Instead of this, they having a band shape structure, right? So they having the band shape structure, and due to this, they show some dipole moment as well. Clear hai? Chalo. Now, what is the method of preparation, right? What is the method of preparation of ether? So basically, we are going to see only 2 or 3 method of preparation of ether. Out of this, Williamson synthesis is very, very important method, right? So this is one of the important method of preparation for the ethers, right? So what the Williamson synthesized reaction basically consists of, beta? So it involved the reaction of a metal alkoxide with the primary alkyl halide. Always remember this thing here. Always consider metal alkoxide with the primary alkyl halide, right? If you want the maximum product to be formed, or if you want to produce the maximum yield, always remember alkyl halide must be primary and alkoxide must be tertiary, right? So tertiary alkoxide and primary alkyl halide gives a maximum yield of this product, right? So basically it involves the reaction of metal alkoxide, basically the tertiary metal alkoxide with a primary alkyl halide, right? And the metal alkoxide is prepared by adding sodium or potassium metal or sodium hydride to the alcohol. So if someone wants to know how this alkoxide is formed, then this alkoxide is prepared by adding sodium or potassium metal to the alcohol. So let me give an example of the tertiary metal oxide and how they react with the primary alkyl, right? So this is like CH3, 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 and this is ONA. Right. So this is CH3, 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 and this is ONA. Now, when they react with the primary alkyl halide like CH3 and Cl, what they form? Right. NaCl is a byproduct of this reaction, and we get CH3, 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 and this is OCH3. So this is the final product we get. Right. Good. Clear? Eh? So this is how will you form the ether. So this is in a structure of ether, right? So this is what we get. This is called ether. So this is the Williamson synthesized method in which tertiary alkoxide is react with the primary alkyl halide to give the ether. Right. Now here we can see that how alkoxide is produced. So whenever the metal hydride is treated with, right, whenever the metal hydride, alcohol is treated with the metal hydride, then the metal alkoxide is formed. So this is the how metal alkoxide is formed. Once the metal alkoxide is formed, they are treated with the alkyl halide to give the corresponding ether, right? For example, here we have propane 1-ol, like CH3, CH2, CH2OH. So we have a propane 1-ol. Now, when this propane 1-ol react with NaH, right? When this propane 1-ol react with NaH, this will give sodium propoxide, right? This is called metal oxide basically. So this will give metal alkoxide, sodium propoxide. Now, when this treated with the alkyl halide, we give the ether, right? So this is what we get. That is called ethoxypropane. So that is one ethoxy and propane, right? So Williamson synthesize involved the displacement of halide ion by the alkoxide ion. So always remember this method, right? Good. Now, the second method for the preparation of alcohol is, reaction of alkyl halide with the dry silver oxide. So this method, we already covered this method of preparation in the alkyl halide chapter. That is the reaction of alkyl halide with the dry silver oxide. So whenever the alkyl halide is treated with the dry silver oxide, or we say Ag2O moist, it will give a ether as well as AgX, or we say some salt of silver. For example, if we have CH3, CH2 and Cl. So 2 mole of CH3, CH2, Cl. And now when we react with Ag2O moist, what we'll get? We get CH3, right? This is O and this is CH3. What the byproduct for this reaction? That is nothing but 2AgCl, right? So this is the byproduct of this reaction. So here we'll get methoxymethane plus 2AgCl. So this is the another method for the preparation of ether, right? Now, the next method is by the dehydration of alcohol. So this is also we already discussed in alcohol chapter. That is whenever we treat alkene at 383 Kelvin, we get diethyl sulfate. When we treat ethanol in the presence of H2SO4 at 413 Kelvin, we get ether. And when we treat alcohol in the presence of H2SO4 at 443 Kelvin, we get alkene, right? So these three reactions we already studied in alcohol chapter. That is the reaction of ethanol with a different temperature. At 383, we get diethyl sulfate. At 413, we get ether. And at 443, we get alkene as well, right? So basically, alcohol undergo dehydration in the presence of protic acid like H2SO4 and H3PO4. The formation of reaction product alkene or ether depends on the reaction condition, especially on the temperature. Because I already बहुत ज्यादा focus किया मैंने इस पे temperature वाले point पे. Why? Because only due to the difference in temperature we get the three different products. At 383 diethyl sulfate, at 413 ether, and at 443 we get alkene, or we say ethene, right? So this is the structure. This is the reaction. When the ethanol is treated with H2SO4 at 443 Kelvin, we get ethene. And when the ethanol is treated with H2SO4 at 413 Kelvin, we get diethyl ether. They are also known as ethoxyethane, right? Also known as ethoxyethane. Now, some physical properties of ether. So what are the physical properties of ether, right? So basically the dimethyl ether and ethyl methyl ether are gases at room temperature. Always remember this thing. Dimethyl ether or ethyl methyl ether are gases at room temperature, while the other homologous are colorless liquid, which characteristics ether smell, right? So starting a few carbons like dimethyl ether and ethyl methyl ether are gaseous in nature. They have a dipole moment of 1.15 to 1.3. Why they have a dipole moment? Can anyone tell me why they have a dipole moment? अभी पढ़ा है. Why they have a dipole moment? What is the structure? What is the structure of the ether? Linear or bend shape? Can anyone tell me? Linear or bend shape? Structure of ether? Anyone? Anyone tell? What is the why the structure? Yeah, I got the one. Bend shape. Very good, beta, right? So bend shape, due to bend shape structure only, they have a dipole moment, right? Due to the partial -2 negative charge on the oxygen atom and the partial positive charge on the alkyl group, right? Bend shape. Very good, beta, right? So due to only they show dipole moment. So their boiling points are found to be lower than the isomeric alcohol. So if you're comparing isomeric alcohol and the same as a ether, their boiling point are lower. Why? Because whenever we talk about the boiling point or solubility, we always consider the very important factor like hydrogen bonding. So basically, hydrogen bonding is responsible for the lower boiling point or solubility of ether, right? So it is due to the lesser hydrogen bonding in them as compared to the corresponding alcohol. Now, ether up to the 3 carbon atom, right, up to the 3 carbon atom are soluble in water due to the formation of intermolecular hydrogen bond as shown below, right? So let me draw the structure of this. So ether basically up to the 3 carbon atom only are soluble in water due to the formation of intermolecular, not intra, due to the formation of intermolecular hydrogen bond, right? So here we can see the structure of the intermolecular hydrogen bond. So this is the ether, right? RRO, and they show hydrogen bonding with the water, and due to this they are soluble. So this is the intermolecular hydrogen bonding. Intermolecular means between the two different molecules, one molecule of ether and one molecule of water, and intra means क्या होता है, कल पढ़ा था, between the same molecule. ठीक है? Now let's move to the some chemical properties of ether as well, right? So what are the chemical properties of ether basically? So we already covered method of preparation of ether. We already covered the structures of ether, already covered the physical properties of ether. Now we are going to cover the chemical properties of ether. So what is the chemical, what type of chemical properties ether generally show? So basically the reaction involving the alkyl group, the first, and the reaction involving the ethereal oxygen. So basically we classify the whole chemical properties of ether into two basic type, right? One is reaction involving the alkyl group, in which this alkyl group is involved in the reaction, and the another in reaction in which the oxygen comes into the picture, right? So we classify this reaction into two major types. On the alkyl group, reaction involving the alkyl group, we have a two reaction, like action of air and light, and the second one is a halogenation. And similarly, with reaction involving ethereal oxygen, we have a two kind of reaction as well. That is action of concentrated acid and the formation of coordination complexes, right? So these two are the very important reaction. Now, one more important reaction. This is the first one. This is the second one. And this is another very important reaction. That is reaction involving cleavage of carbon-oxygen bond, right? So with the halogen acid, with H2SO4, with PCl5, with the acid derivative. So we classify the chemical properties of ether into three types. जल्दी बताओ, सबको समझ आया यहाँ तक? Is it clear to everyone? How we classify the chemical properties of ether on the basis of three main reactions. That is reaction of alkyl group, reaction of ethereal oxygen, and the reaction involving the cleavage of carbon oxygen bond. Clear है? चलो one by one देखते हैं basically. So the first is reaction due to ethereal oxygen, right? So what is this due to the ethereal oxygen? So basically these reactions are mainly due to the lone pair electrons of oxygen. So this reaction are mainly due to what? Due to the presence of lone pair electrons of oxygen, right? So here ether behave as a base. Always remember this thing. Why they are called base? They are behave as a Lewis base, right? They behave as a Lewis base. Why they behave as a Lewis base? Because they have a lone pair of electrons. So the tendency to donate lone pair of electron is known as Lewis space, right? So these reactions are mainly due to the lone pair of electron of oxygen, and ether behave as a Lewis space. Why Lewis space? Because they have the lone pair of electron, right? Due to such electron, following reaction are shown by the ether, right? So due to the such electrons, following reaction are shown by the ether. So what are the following reaction? Beta फटाफट देख लेते हैं. The first one is action of concentrated acid, right? That is the action of concentrated acid. So basically, oxonium salt are formed, right? Oxonium salt are formed. Such salt are formed when the H plus of acid accept one of the lone pair of oxygen, right? So how will this form? Basically, we know that acid have a proton capacity, right? So whenever such salt are formed when the H plus of acid accepted one of the lone pair of oxygen. चलो देखते हैं फटाफट. So this is the ether. We know that in ether, oxygen having two lone pair of electron, and this is nothing but acid. So acid having H plus and Cl, acid having a strong tendency to protonate H plus. Now this H plus wants कि उसको कोई इलेक्ट्रॉन दे दे, and ऑक्सीजन हैविंग टेंडेंसी टू गिव लोन पेयर ऑफ इलेक्ट्रॉन. सो ये क्या करेगा, अपना एक इलेक्ट्रॉन H प्लस को देके अपने साथ कंबाइन कर लेगा. सो O पे क्या चार्ज आया, O पे आ गया है पॉजिटिव चार्ज. सो दिस RRO having the positive charge, Cl negative, right? So these salt are stabilized due to the presence of the anion of acid as shown below, right? So this is the dimethyl ether we have, CH3 twice O, and this is the H2SO4. So whenever this dimethyl ether is react with this H2SO4, what they form? Diethyl oxonium hydrogen sulfate. Always remember this thing. Diethyl oxonium hydrogen sulfate. So the formation of salt takes place. So due to the ethereal oxygen, due to the donation of lone pair of electron, salt formation takes place. जल्दी से सभी बताओ ये वाला रिएक्शन क्लियर है क्या? Is this reaction clear to everyone or anyone having any kind of doubt? You can ask beta फटाफट. Confirm me once. Is this clear to everyone? Yes, I'm waiting for a reply. Everyone just reply. Yes, GNV Shangal, good. So basically the formation of salt takes place due to the lone pair donation. Yes, beta. Osamabad, very good. Now, this is the second reaction. This is also an example of ethereal oxygen as well. So ethereal oxygen being the Lewis base from coordinate complexes called etherates with the Lewis acid. So what is this coordination complexes? Basically, you are going to study this chapter as well in your coordination compound chapter. That is coordination complexes. So when the complexes is formed, complexes is formed by the two things. That is one which behave as the Lewis acid and one who behave as the Lewis base. So Lewis base having tendency to donate the lone pair of electron, and Lewis acid having tendency to accept the lone pair of electron. And due to this, the coordination complexes are formed, right? So ethereal oxygen being Lewis base from coordination complexes called etherate, which Lewis acid, right? So can you name some can you name some Lewis acid examples? Anyone? Examples of Lewis acid. What are Lewis acid? Can anyone? What are the Lewis acid basically? Those having the deficiency of electron or those having the maximum number of electrons? AlCl3, AlCl3. Very good, very good. Okay, Bhavnagar, good. So those having the deficiency of electron is known as Lewis acid. We all know this thing. They're having the strong tendency to accept the electron, right? So they're having the strong tendency to accept the electron. That's why they are called Lewis acid, right? So basically, BF3, AlCl3, FeCl3, Grignard reagent, the equation of this reaction, let's see, right? So these all are the example of the Grignard reagent. Always remember this thing. So this is what we have. This is CH3, CH3O. So this is the, what this is? This is the ether. And this oxygen having the lone pair of electron. Now this BF3 is the Lewis acid. They strongly want electron because they have only 6 electron in the boron atom. So they generally want कि एक electron कहीं से मिल जाए. So they form complexes. How they form complexes, beta? They form complexes. देखो ध्यान से. अब हम सबको पता है कि ये BF3 है. This is BF3. Now, boron having only how many valence electron boron having? Only 3. Because boron का atomic number 5 होता है, so they having only 3 valence electron. So they having only 3 valence electron. So they are able to make only 3 bond. Now, अगर वो ऑक्सीजन इलेक्ट्रॉन डोनेट भी कर रहा है तो ये बॉन्ड तो बना नहीं सकता. बॉन्ड कब बनता है? जब एक इलेक्ट्रॉन बोरोन का हो, एक इलेक्ट्रॉन ऑक्सीजन का हो, फिर बॉन्ड बनेगा. Here the formation of bond, how the formation of bond takes place, beta? Can anyone explain? Because boron do not have any unpaired electron. They have only 3 electrons and 3 bonds are formed with the fluorine. So how will they form another bond with the oxygen? Can anyone? Yes, they form coordinate bond. So they are the special type of bond in which the both the 2 electrons in bond are present of the same atom, right? इस केस में जैसे ये coordinate bond है, तो इस bond में 2 के 2 इलेक्ट्रॉन ऑक्सीजन के ही होंगे, right? इसमें कोई भी इलेक्ट्रॉन बोरोन का पार्टिसिपेट नहीं करेगा. And this type of bond are known as coordinate bond. Always remember. So we have a 2 type of bond now, covalent bond, right, in which the one electron of each atom are shared between them, they make the bond, right? And the another bond is called coordinate bond that we are going to see in the coordination complexes, coordination compound chapter. So they are the special type of bonds in which the 2 electron are present of the same atom, right? So this bond is formed between this BF3 and this ether, right? Coordinate bond. So this is termed as boron trifluoride etherate, right? Similarly, when we treat with the RMGX, what is this RMGX? Can anyone tell me the name of this RMGX? What is this RMGX? Last chapter में भी बात किया था हम लोगों ने. What is this RMGX? Can anyone? Can anyone tell me what is RMGX? Yes, Grignard reagent. Very good, beta, right? So this is the Grignard reagent. Very good. So this Grignard reagent is also behave as a Lewis acid, right? Good. How can we give the IUPAC name, sir? Okay. IUPAC name of which compound, beta? This one, boron trifluoride etherate. Yes, beta, this is the basically this is not the IUPAC naming, na? This is the common name of this, right? This is the common name of this salt. This is the boron trifluoride etherate. What is etherate basically? So always remember this. Whenever the salt formation of ether takes place, it always named as etherate. Always remember this thing. And here we have a BF3, which is named as boron trifluoride and etherate, right? So this is known as boron trifluoride and etherate. Etherate means we have a ether here. So always remember this thing. Whenever the oxygen, the ether oxygen having lone pair of electron make salt, they are always known as etherate. देखो यहाँ पे already हम लोगों ने discuss किया था. The reaction are mainly due to the lone pair of electron of the oxygen. Here ether behave as a base. राइट, तो ईथर किसकी तरह बिहेव कर रहा है? बेस की तरह. और किसकी तरह रिएक्शन हो रहा है? ड्यू टू द लोन पेयर ऑफ इलेक्ट्रॉन. सो ऑक्सोनियम सॉल्ट आर फॉर्म, राइट? So they all are known as ether. For example, here this is the ether, right? This is the ether, and this is the dialkyl oxonium chloride will be formed. Similarly, in this case, ethereal oxygen being the Lewis space, they form coordination complexes called etherate. So always remember, whenever the ethereal oxygen which act as the Lewis space, they form coordination complexes. They are always known as etherates, right? So उसको हम क्या बोलेंगे बेटा? Etherates. So this is known as boron trifluoride etherate. Clear है? चलो. Now, the second reaction is reaction involving cleavage of the carbon oxygen bond, right? So this reaction involves the cleavage between carbon and oxygen bond. So first two reaction is the reaction due to the ethereal oxygen, and now we are going to see the reaction involving the cleavage with the carbon oxygen bond. So cleavage with the carbon oxygen bond result to the following reactions of ether, like with the HX, like HCl, HI. The reaction of dialkyl ether with HX give 2 alkyl halide molecule. For example, here we have ether and here we have HX. So what we'll have? We have alcohol and alkyl halide. Similarly, when this alcohol again react with this HX to give again alkyl halide. So in this, the reaction of dialkyl ether with HX give the two alkyl halide. In the first step, alcohol and alkyl halide form. In the next step, again alcohol react with this alkyl, this HX, right? This hydrogen halide to give alkyl halide again. So in this, we get the two alkyl halide molecule. Now, if someone asks the order of reactivity of the halogen acid out of HI, HBr, and HCl, right? HF is very, very reactive, so we cannot, the reaction become explosive in nature. We are not using HF, right? Their bond dissociation energy is also very, very high. So just we use the order of reactivity of halogen acid like HI, HBr, and HCl. So out of HI, HBr, and HCl, the reactivity of HI is very more as compared to HBr and HCl. Why this is? Because we know that if we are comparing the HF, HCl, HBr, and HI, right? So these all are the hydride of the 17th group, right? So this reactivity of the hydride increase down the group. Why? Due to increase in the size. If we consider the HI, their size is like this. If I'm considering HBr, their size is like this. If I considering HCl, their size is like this, right? So as the distance between the two atoms, as the size of the two atoms increases, the bond become weakened. They easily break, right? तो ये बॉन्ड जल्दी टूटेगा और रिएक्टिविटी भी जल्दी शो करेगा. तो जैसे जैसे बॉन्ड बढ़ता जाता है ना, साइज एटम का बढ़ता जाता है, उसकी रिएक्टिविटी भी बढ़ती है, राइट? सो रिएक्टिविटी ऑर्डर क्या हो जाएगा बेटा? HI का सबसे ज्यादा रिएक्टिविटी, देन HBr एंड HCl. सो दीज आर द रिएक्टिविटी ऑर्डर ऑफ दिस, राइट? नाउ in case of asymmetrical ether, the alkyl halide is always formed from the a smaller alkyl group, provided no tertiary alkyl group is present. Always remember. So in case of asymmetrical ether, so this is the symmetrical ether, right? So in this, there is no problem. But if you're talking about the asymmetrical ether, the alkyl halide is always formed from the smaller alkyl group, provided no tertiary alkyl group is present, right? If any tertiary alkyl group is present, the halogen get attached with it, right? So let me explain this with the example. Here we have an example of methoxyethane. So this is a asymmetrical alkyl halide, we all know. Sorry, this is a asymmetrical ether, right? So this is known as methoxyethane, asymmetrical ether. Now when we react with the HBr, which one is the smaller group? This methoxy is a smaller group now. This ethoxy is a bigger group. So this methoxy is a smaller group. So always alkyl halide is formed by the smaller group. Remember this, formed by the smaller group. So this is CH3Br and this is CH3CH2OH. Right. So this is very much clear. Always remember this thing. Whenever the ether is treated with HBr, alkyl halide is formed always by the smaller alkyl group of the ether, right? Now, in case of the tertiary alcohol, tertiary ether, so this is an example of tertiary ether we have, right? So this carbon having 3 alkyl group, yeah, like this, like example of tertiary ether. Now, when this tertiary ether is react with HI, what they say? If any tertiary alkyl group is present, the halogen get attached with it. So halogen वहां पे जाके क्या हो जाएगा बेटा? Attached हो जाएगा. And in case of alkyl aryl ether, the products are always phenol and an alkyl halide, right? So in case of alkyl aryl ether, the product are always phenol and alkyl halide ether. So यहाँ पे देखो I यहाँ पे connect हो गया, दिख रहा होगा साफ साफ. ये I कहाँ connect हो गया? यहाँ पे. That is called CH3OH निकल गया, and this I is substituted to this carbon atom. Now, in case of alkyl aryl ether, the products are always phenol and alkyl halide. So always remember this case. In case of aryl ether, also known as anisole. So the common name क्या है बेटा? Anisole. Remember this thing. Right. So this is the common name of the ether, that is anisole. So in case of anisole, or we say aryl ether, always phenol and alkyl halide will be formed. So this is very important. So सभी points इसके याद होने चाहिए तुम लोगों को. कई बार reactions में सीधा आता है यहाँ से. What happened when the methoxyethane is reacted with HBr? So always remember smaller group का alkyl halide यहाँ बने. ठीक है? चलो. Now with the sulfuric acid with the dilute H2SO4 under the pressure, ether are hydrolyzed to alcohol, right? For example, we have a ether, and when treated with the dilute acid, that is H2SO4, under the some pressure, but you will get 2 molecule of alcohol. Similarly, with the concentrated H2SO4, alcohol and alkyl hydrogen sulfate are formed. So remember this point. When we treat when you treat ether with the dilute acid, then only alcohol will be formed. And when we treat with the concentrated H2SO4, then what form? Alcohol as well as hydrogen, alkyl hydrogen sulfate will be formed. Right. So these all are the reactions. Now, this is the last reaction of the ether. That is the reaction involving the alkyl group. Right. So what is the reaction involving the alkyl group basically? So action of air and light when exposed to air and light for the long times, ether are oxidized to form hydroperoxide or simply peroxide. Right. Always remember, whenever the ether are exposed to air and light for the long time, they form hydroperoxide or simply peroxide. The reaction is the free radical and oxidation occur at the carbon atom next to the ethereal oxygen. And oxidation kahan hoga? Ethereal oxygen ke next carbon atom pe. Right. These peroxide are very dangerous compound as these decompose violently at a high temperature. So these are very, very dangerous compound because they decompose ho jate hain high temperature pe jaake. So let's see an example with this, right? So we have a diethyl ether, right? We have a CH3, CH2O, CH2, CH3. So this is an example of diethyl ether. Now, when we treat diethyl ether with O2 in presence of light, what they form? The oxidation takes place occur at the carbon atom next to the ethereal oxygen, right? So this is the ethereal oxygen. So this is the ethereal oxygen having the 2 lone pair of electron. So this will take place next carbon atom. For example, this carbon atom, right? So this will convert it into COOH. This is CHOOH. So this is the oxidation of the ether will take place, right? Now, the next reaction is halogenation. So with the halogenation, ether gives substitute product, and the extent of halogenation, however, depend upon the reaction condition only. Always remember, right? For example, diethyl ether react in dark to form only mono-substituted product, where in the presence of light, they will form some different product, right? So always remember this thing. So halogenation ether give the substitute product, and the extent of halogenation, kitna halogenation hoga, ye totally depend karega. Yes, JNB Gandhinagar, you want to ask anything? Chalo. Right. So that is with the extent of halogenation, however, depends upon the reaction condition only, right? It depends upon the reaction condition only, where you take the, where you consider this reaction in the light or in the dark condition, right? So basically, diethyl ether react in the dark to form only mono-substituted product of the alkyl group, right? For example, this is the diethyl ether. When they react with the Cl2 in dark, they will form alpha-alpha dichlorodiethyl ether, right? Only mono-substituted. Alpha-alpha dichloro. So we have a one alpha carbon here, one alpha carbon is here. So we have a alpha-alpha dichlorodiethyl ether. But in presence of light, right? In presence of light and excess of chlorine, all hydrogen atom are substituted. So they form like C2Cl5, C2Cl5. So all hydrogen are substituted. And in place of hydrogen, we get the Cl. So always remember this thing. In presence of dark condition, only mono-substituted product will be formed. But in presence of light and excess of chlorine, all hydrogen atom are substituted. Clear? Hai? Chalo. So these are the, or we say the roadmap, right? Mind map of this ether chapter. Basically, we already covered the physical properties, right? Melting, boiling, solubility, chemical properties in which we study the breaking of CO bond, reaction with HX, right? And different type like ethyl oxygen का reaction क्या होता है and this nomenclature we already know alkoxy alkane preparation dehydration of alcohol Williamson synthesis symmetrical or asymmetrical ether so already we cover all this thing right they already use as a solvent due to their low reactivity ठीक है तो ये already हम लोग सारा cover कर चुके हैं now let's move to do some important question right related to all the alcohol phenol and ether chapter right so ये combine है सभी से रिलेटेड है ये ठीक है तो जल्दी फटाफट बताएंगे मुझे दिस रिएक्शन द इलेक्ट्रोफाइल इन्वॉल्व कैन यू नेम द रिएक्शन बेटा कैन एनीवन नेम द रिएक्शन व्हिच रिएक्शन इज दिस कैन एनीवन नेम द रिएक्शन व्हिच रिएक्शन इज दिस then only you are able to classify the electrophile involved in this reaction right first of all you name the reaction can anyone no किसी को ध्यान नहीं आ रहा है चलो beta this is the RTM reaction Raymond Timon we already discussed this reaction in the previous class Reimer very good beta right so this is the RTM reaction now what the electrophile involved in the reaction can anyone name the electrophile involved in this reaction can anyone name the electrophile involved in this reaction yes I got one yeah B someone says B anyone कोई कुछ और बोलना चाहता है okay let me write the reaction so that you understood well this is CHCl3 now when they react with the NaOH right what they form basically CCl3 right negative CCl3 and here H2 right here also one chlorine is removed so what you will get you will get CCl2 right so this is act as a electrophile C no beta that is this one dichlorocarbene always remember this dichlorocarbene act as a electrophile in this reaction right so dichlorocarbene act as a electrophile in this given reaction okay chalo now can you name the product X in the following reaction can anyone product X in the following reaction can anyone want to name this reaction this is the secondary alcohol and we treat secondary alcohol with NaIH3PO4 in next step we treat with the MgN dry ether and the third step with the hydrolysis with D2O can anyone name this reaction Sure. I will explain you. So this is CH3. This is CH2, right? This is CH, OH and CH3. So we know that whenever the alcohol is treated with, right? Whenever the alcohol is treated with NaCl in presence of H3PO4 or NaI, so this reaction is known as halogen exchange method, right? H3PO4. What they form? They form CH3, CH2, CH, I, and CH3. Right. So this is the simple reaction of alcohol with the alkyl halide. So we know that whenever the alcohol is treated with the NaIH3PO4, we'll get this. Right. Now, when this alkyl halide is treated with the Grignard region, right? This is Mg in presence of dry ether. What they will form? Dry ether beta. Fatapat, jaldi se batao. So they will form CH3, CH2, CH, Mg and I, right? And this is nothing but CH3. Now again on hydrolysis, right? On hydrolysis, what they will form? They will form CH3, CH2, CH, here D, and this is CH3. right? So this is the product we get. So this is the final product for this reaction. समझ आया सबको? सो इस तरीके से बेटा इसको करना है। तो हम लोगों ने इस पूरे चैप्टर को भी ऑलरेडी कवर all the important points, all the important concept of this chapter. We already cover all alcohol, phenol, and ether in today class. In almost we took 4 class for the complete of this chapter. So I just request you to revise all this thing, right? Revise all this thing and start solving and practicing question as much as you can, right? So start solving question. So just revise thoroughly all alcohol, phenol, and ether, what we discussed, right? And after this, after you start solving questions related to previous year question or NEET or JEE or advanced question, right? Then only you are able to learn this chapter in a very good way by practicing questions, right? So anyone having any kind of doubt? Yeah. Right? So no one? सब clear है? No. Good. So just revise the whole concept, beta. Meet you soon in the next class. ठीक है? जब तक आप लोग इसको अच्छे से रिवाइज करो. Okay? Take care all.